Okay, what I'd like you to do is solve this problem yourself. I'm going to present the problem and lay out the steps for solving the problem. And then at that point, you should pause the video and you should attempt to do the problem to completion and then follow the steps afterwards. If all you do is just watch how the problem's solved, you really won't get anything out of it, nor will you remember it. So here is our problem. We have a mass 2 of 5 kilograms. It's connected by a rope over a pulley that has a radius of 0.1 meter and 10 kilogram to another mass M1 that is 10 kilograms. And I show the anticipated direction of acceleration. The pulley itself is a solid cylinder. It has a tabulated value for its moment of inertia, and it's rotating around its center of mass. So your first step is to draw the free body diagram, and then your second step to obtain from the free body diagram the equations of motion. And then once you've got the equations of motion, find the acceleration. So at this point, pause the video and work out the problem. Assuming that you have paused the video and worked out the problem yourself, the first thing I want to do is go over the free body diagrams. And we see here that for mass 2, we have the force of tension 2 in the upward direction, in the direction of the anticipated acceleration, and the force of gravity m2g. For the pulley, we have our anticipated direction of angular acceleration, and we have a force of tension 2 acting at radius r, and a force of tension 1 acting at radius r in the opposite direction. And then for mass 1, we have a force of tension 1 acting in the upward direction, and the force of gravity acting in the downward direction, and acceleration in the downward direction. And we will take as our positive direction the direction of acceleration A. So now our goal is to obtain the equations of motion from the free body diagrams. Okay. So we have for the first one that the force of tension 2 minus m2g equal to mass 2 times the acceleration. For our torque equation, we have minus the force of tension 2 times the radius r plus the force of tension 1 times the radius r is equal to the moment of inertia times alpha. And for M1, we have mass of 1g minus force of tension 1 equal to M1 alpha. At this point, you should realize what steps are necessary to solve for acceleration A. Now we first ask, how is alpha related to A? And solve for the acceleration. First thing I want to do is I'm going to write force of tension 2 equal to mass of 2 times acceleration minus mass of 2 times gravity. And the force of tension 1 can be similarly written. I'm then going to take each one of those. I'm going to take the force of tension 1 and substitute it. I'm going to take this one and substitute it over here. And I'm going to substitute for alpha A, the linear acceleration A over r. Performing those substitutions, I can carry out the algebra and find out that and have everything in terms of r and a. Now let's finish the problem, and I'll leave that up to you to finish it. End of module.